All right, well, good afternoon, everybody. Today we are doing our third lecture for Unit 2.3. And just to give you a quick reminder of what Unit 2.3 is, remember it's about carbon, right? And what we've done so far are carbohydrates. We did 2 lectures on that. And today we're going to be going over lipids, which are also known as fats. Okay. What these guys are, remember there are macromolecules, okay? And we're going to be doing the third and fourth one this week. But today, again, we are focusing right there on lipids, which are fats. So, the thing about fats, right, lipids are fats. The thing about fats is when you think about your diet, you don't really want to be eating many fats, right? You know that they're not very good for you. Any health class that you've taken, or I'm sure even your family at home, they have tried to reduce this in your diet, okay? And this is because fats are a rich source of energy. The fats themselves provide more energy than carbohydrates. And if you guys recall, this includes things such as pasta, bread, and even candy. Okay? On a molecular level, carbs and fats are really similar, actually, which is kind of funny. They have this backbone that is very similarly made up of carbon, hydrogen, and oxygen. So they're all made up of C's, H's, and O's, right? Carbons, hydrogens, and oxygens. The big point that I really want you to understand about fats is right here, though, okay? There are 2 main types of fats. One is called saturated, and the other is unsaturated, okay? And the way that I really want you guys to think about this is that saturated fats, think of them as bad fats, okay? We only want to eat very few. And this is because they're known to contribute to things such as heart disease and many, many other things. But this is definitely a lead one that you can always associate with this. And this is because these type of fats, these saturated fats, are actually able to clog certain areas in your body and prevent blood from flowing. So not good. Now, unsaturated fats, we're going to think of these actually as good fats. These are fats you actually need in your diet, and they include things such as vitamins. Okay, so you do need some fat in your diet. The thing is you want that to be the good fat, right? We don't want it to be the bad fat. So if you guys look right here, we're showing you first, stick with our color scheme, we're first showing you a saturated fat. And what I really want you to pay attention to, see what size I made that. Let's try this out. A little bigger than that. What I really want you to pay attention to is this middle area Okay, and what I want you to note about all of these carbons is that saturated fats only have single carbon-to-carbon bonds. That is, you'll only see this right here, okay? This idea that we only have, okay, that one dash between the C's, all right? There are no double bonds. S fats, saturated fats, have no double carbon-to-carbon bonds. Now they do have, if you notice here, they still can have a C to O. That's fine, but there aren't going to be any C's double bonded to C's. There's going to be no carbons double bonded to carbons. And examples of saturated fats are fats that are solid at room temperature. So the main one is really butter. Okay, now think about it, right? If you take butter and you put it on a room temperature or cold piece of bread, that butter is not actually going to melt, right? The only time that butter is going to melt is if the bread is warm. So unsaturated fats are a little bit different. Okay, so we're focusing on this fact that they're unsaturated. Okay, and the big thing comes right there. Okay, it's the fact that they have C's double bonded to C's. That's how you can identify an unsaturated fat. So we can say they're identified by this double bond here. Okay, now they still do have single bonds, there's plenty of them, but the fact that they have this double bond is what allows them to be liquid at room temperature. And this is due to the carbon to carbon double bond. Okay. Examples include, the big one would be like cooking oil. Okay. Sunflower oil, olive oil. These are all liquid at room temperature. Okay, and that's the big difference. They don't need to be heated to actually be liquid. Okay, so that is the big difference between a saturated fat and an unsaturated fat. Again, saturated fats, they're solid at room temperature, and they only have single carbon-to-carbon bonds, whereas unsaturated fats are liquid at room temperature, and they can have they need at least one carbon-to-carbon double bond, and sometimes they even have more, okay? What we're going to learn next is what the structure of an individual lipid molecule looks like, okay? So this is an individual lipid molecule. Right? And that's what we're seeing right over here on the right. This whole blue circle head, yellow tails, that's an entire lipid molecule. Okay? And what we say about this is that the head is hydrophilic. Hydrophilic. Okay, and the tails, by the way, this is the head. Okay, this whole area here is the head. And the tails are said to be hydrophobic. Okay, and the tail is this whole yellow area right there. Okay, I know these are big words, but we're going to get into what they mean right now. The word hydrophilic means water-loving. Okay, so these heads, these blue lipid heads, we're going to keep calling them a head, okay? They like to be around water. They're attracted to water. They're really okay with being around water, okay? Whereas the word hydrophobic means water-hating. What I want you guys to think about is how we can actually have something, right? If you have the word phobic here, think about what the word phobia means. Have you ever heard of arachnophobia? No? So what arachnophobia basically is being scared of spiders, okay? Anytime there's the word phobia means scared. Okay, and so what happens is that when we're saying that these tails are hydrophobic, it really means that they are scared of water. Okay, so we can say that the tails are hydrophobic. Okay, which means they're scared of water. Okay, whereas the heads are hydrophilic. And they love to be around water. Okay, and so what we see happen, because these tails, they hate water so much, okay, what we see happen is that when these tails are in water, they actually aggregate all together. And that's what you're seeing on the very inside here. You see all these tails actually come closer together. And the reason we're talking about this is because lipids, right, these individual lipid molecules with these heads and these tails, they make up our cell membrane, okay? And what they make up here is what's known as a lipid bilayer. And this is a fancy way for just saying that this cell membrane has it's got two layers, right? And if we look back at this photo, that's exactly what we see. You'll see that there's one layer, right, on there, and we have our other layer here, right? So it's made up of these two layers because these tails are so hydrophobic, they can't face the water at any point, right? They have to face inward towards each other. Okay, so the hydrophilic heads face the water outward, right? While the hydrophobic tails face the inside towards each other. Right? And again, that's exactly what we're seeing, okay? If we look at this great photo we have here, you'll see that we have all of our hydrophilic heads, on both sides, right? And these guys are totally cool with facing outwards towards the water, right? They are water loving, they're hydrophilic. Now this is in great contrast to these hydrophobic tails. And we got a bunch of them here. And what you guys can show is, like, if you put little arrows on the very end of them, like I'm doing, right, it shows you that they're really facing inward towards one another, right? Hydrophilic heads, they go out towards the water. Hydrophilic tails are inward towards one another, okay? And if you guys want to just label this, it's very easy. All you have to do is put head, right? These are our tails. and these are more of our heads, okay? And again, this whole entire thing, the lipid bilayer, is considered to be the heads and tails, okay? Which I think is an important designation. Oops. Okay, it's not just one or the other, it's literally the heads and tails of everything within this lipid bilayer. Okay, so that's our lecture, pretty short and sweet today.